Hopefully you've already watched the first video on test of significance, which was the concept video. This is now talking about a little detail, one-tail versus two-tail testing. Let's look at two examples. One is the daily ridership on the S8 train in Frankfurt. We have 2,384 people on average, sample at mean, with sample standard deviation. Day of a concert, we have 3,317. Is there convincing evidence that the concert increased ridership? Right. The other example, right, we have over the last 10 years, 8% on average of the 10th, 11th, and 12th graders at an international boarding school, for example, have been American. The current 11th grade has 92 students, 6 of which are American. So we're also looking for convincing evidence that the number of American students in this year's 11th grade class is significantly different than the average. So the difference between one-tail and two-tail is how the question is asked. So let's look at the sampling distributions for both. Right, they're both going to be either a Z or T distribution. And if we look at where the centers are, of course, we know that the centers of the sampling distribution is the population mean. Now, we don't know the population mean here, but we're going to use the sample mean as an unbiased estimator. And here we do know, over the last 10 years at least, a pretty good number of 8% will be the center of this sample distribution of sample proportions. Of course, now we're talking about a proportion of classes. Now, in this first example A, the one word which is most important is this increased ridership. We are not the least bit interested in whether it decreases or not. Our hypothesis is that because there's a concert, there's going to be more people. So if we were to locate this 3,317, it'll look something like this. And if we want the probability, we're going to get this area under the curve, and that's going to allow us to do the same judging that we did like with the coin game to see if it's a fair game or not. Well, this is the probability that we're going to get. And it's only on one side because we're only interested in the increase. So that's called one tail. Now notice up over here in example B, we have a different word. And we're asked, is the 11th grade class significantly different than the average? By different, it could be either greater or less. Now, if we calculate what the sample proportion is, it turns out to be 6.5%, which happens to be on the lower end, but again, we don't actually, our hypothesis doesn't conjecture one direction. So if this is due to random chance, it's just as probable below as it is above. So we could get a symmetric point above and say, well, it could have been that if there was no significant difference. And so what we're going to do is get the area of both sides as our probability. And that's what we're going to use to judge whether it's a random event or whether it truly is significantly different. So that's called two-tail. And that's really the only difference between one-tail and two-tail.